Let's talk about range.
Your board's broken.
Here we go. All right. So we're talking about, we're going to still work through 1, 2. We might get through the rest of it today. It might be part tomorrow. But we're going to look at range today and some other characteristics of graphs. So yesterday we talked a lot about domain and how to find domain algebraically, right? Looking for a radical, looking for a fraction. So today we're going to talk about range. But we're going to talk about range graphically. So you're going to need your calculator. Uh-oh. Somebody? Anybody? Thank you again. So nice to volunteer. All right, so domain describes x's, and if you looked at the graph, you would see, let me show you, for instance, the square root of x minus 1 looks like this. Okay, and when we found that domain algebraically, we would say, well, you know what? X minus 1 needs to be bigger than or equal to 0. So x needs to be bigger than or equal to 1. And if you look at the graph left to right, and that's my x, do you see why that's the domain? From 1 over is the only place the graph is. Does that make sense to you? Do you see what I'm saying here? This means yes, y'all. This means no. If I'm looking at the x's, if I look left to right, I'm talking about domain. I'm talking about, we did it yesterday, we did it algebraically. I'm showing you graphically what it looks like. So at 1 it starts and it picks up and it goes forever that way. Does that make sense? Yes. So you see why? Yes. Okay. So now range is my y, right? So if I want to talk about range, I want to look from the bottom up. Bottom, because we are only going to do range graphically. What is the lowest point on the graph? And looking at this particular one, how low does it go? How low can you go? 0. That's the lowest it goes, right? Does it include 0? Yes, so I'm going to put a bracket. And then it just goes up forever. Nothing stops it, right? So the range is from 0 to infinity. The domain was from 1 to infinity. Let's look at another graph and see if we can get the range. Bottoms up, bottoms up.
God, you.
Look at this graph. Quadratic. Opening up the vertexes at 0, 1. Tell me, looking at it, what is the domain? Left to right, remember. What do you think the domain is? Yes. Now look at the range. From the bottom up to the top. Say again. This point is, it's got the vertex at 0, 1. 1. Let's look at another one. Hopefully this is pretty easy. I hope you've seen domain and range before. You don't remember? Vertex on this one is at 0, 0. What's the domain? What do you think the range might be? Close. Negative infinity to 0. You want from the bottom up. Okay, you don't want to start with 0. You want the smallest it can be up to the biggest. Ooh, try this one. Okay. It's not supposed to cross. It's been glitching like that all day. This is the graph of 1 over x. Tell me what you think the domain. I gave you the graph and the equation. What do you think the domain of this is? What do I have in the equation? A fraction. When I have a fraction, what can I not have? A what? A 0 in the bottom. That's exactly right, Sally. I'm gonna leave 0 out. I'm gonna go negative infinity to 0. And then 0 to infinity. Remember those back-to-back parentheses will leave out just one number. So if you look left to right, it's forever left. So then I go, and I stop at 0, and I pick back up that way. How about the range, though? Anybody? Anybody? What's the lowest the graph can be? Negative infinity. When you start going up, you're close, 0. Because look, it's never crossing this axis right here. It's literally the same thing as the domain. See what we're doing here with range? Yeah. Can everybody find domain and range? Before I move on, can you find it? Yeah. Okay, let me show you another one. Let me give you some values here.
What are we doing now?
Another range. What do you think the domain is? Domain describes what? It describes the x. It's negative infinity to infinity. The range is going to be the one that's a little bit harder. Bottom up. Negative 5. Do we all see why it starts at negative 5? It's the lowest point on the graph. As I go up, where does it stop? Infinity. It never stops. There's never a place where there's no graph. It keeps going. So negative 5 to infinity. Yes or no? All right. Let's talk about continuity then. What we're doing. What? I didn't say anything. I said continuity. And then they said something. What we're doing here is we're working up, domain and range being 2 of them, we're working up to a full analysis of functions where we will look at a particular function, you will graph it, and you will answer all these questions about it. What is its domain? What is its range? What is its continuity? What is its, and so on, and all the different things that we're learning. Okay, so that's kind of what we're building up to here. That's why it seems like we're going in a little bit of pieces. All right, we have 2, 3. Well, let's first define continuous, because that will make a little more sense. For right now, we're going to define continuous as a function that when you draw it, this is the easiest way I know to describe it. When you draw, you never lift your pencil up. Okay, that's how we're going to describe it from right now. We will build on this definition a little bit to include some where you do have to lift your pencil up, but they're still continuous for various reasons. But for right now, things like this, see how I drew that and I didn't have to lift my pencil up? That's a continuous function. Okay. However, if I did something like that is not a continuous function. I can't draw it. It's not all smooth and connected. All right. If it is not continuous, we say it has a discontinuity. And so we're going to talk about some different types of discontinuities. The first type of discontinuity is what we're going to call a removable discontinuity. And you will see this when you graph it. So what happens is I am chugging right along on this graph, and all of a sudden I hit this hole in the graph. And then it continues on to do its thing. And then where this hole is, there's a solid dot up here. That is a removable discontinuity. It literally looks like somebody took the graph and took a point out of it and then just stuck it somewhere else. They removed it and stuck it somewhere else. That's a removable discontinuity. It's still a function. It still passes the vertical line test, but it's got some strange things going on with it. Okay, can you recognize a removable discontinuity? Okay, sometimes that removable discontinuity may not have another point with it. It might just be a hole in the graph. Okay? Still, it's removable. You could literally take it out of the function. All right, then we have what we call, this is my favorite one, a jump discontinuity. So a jump discontinuity, I kind of already drew it for you. Starts this graph and then it stops and it picks back up here and it continues the graph on. That's a jump discontinuity. And it looks exactly the way it sounds to me. It looks like the graph starts, it stops, it jumps up here, and then it continues. Jump discontinuity. Anybody confused? Everybody good? All right. One more. This one is called an infinite discontinuity. Most of the time, these are caused by asymptotes. Remember what asymptotes are? Kind of. So an asymptote on a graph is this, and it's that 1 over x had an asymptote. It's an invisible boundary, and it's usually written as a line, okay, that the graph gets really close to, but it never actually touches. So that one we did before that was 1 over x that looked like this, right? There's an asymptote right here. Okay. We call these infinite discontinuities because each piece is continuous on its own and they go on forever, but because they go on forever and ever and there's more than one piece to it like this, it's an infinite discontinuity. that make sense? I feel like these are really big words. Will somebody pick that up? For pretty simple concepts. We're not going to do much more just yet with it than just identifying continuous, not continuous. If it's not continuous, what's the type of discontinuity? At least one more type of analysis. Let's do increasing and decreasing. Like I said, you're going to have to graph these on your calculator and look, so I'm going to need to give you time to get it done. So still, we're still in it. In it to win it. Yes. All right, this is an easy concept. All right, so you will tell me over what intervals the function is increasing and over what intervals the function is decreasing. So let me show you an easy example first. Increasing basically means as you move left to right, the graph goes up. As you move left to right for decreasing, the graph goes down. Here's my parabola. Vertex at 0, 0. Starting from the far left, as I move from the left to the right, left to right, is the graph going up or down? It can go up, down, or be constant. What's it doing? This piece right here, what's it doing? Left to right. From here to here, is it going up or down? Down. We say that's decreasing. It stops here and it starts to do what? Increase. If this is 0, 0, over what interval is the graph decreasing? Negative infinity to 0. Do you see why? Left to right. Left to right. Over what interval is it decreasing? We know it is here, right? So from left to right, it's always decreasing until it hits 0. So negative infinity to 0. When I talk about increasing and I move over here, it starts increasing where? At 0, and it always increases from there on out. That should probably be a parenthesis. You see what I'm saying? Do you see what it's doing? See how to tell if it's increasing or decreasing? Let's do one more. I'm going to get this one out of your book. And I'm going to make this not, we'll make it continuous. There's my graph. This one has a constant also. Increasing, decreasing, constant. All right, you tell me, where is it increasing? Where does it go up from left to right? Where? On the right side. So we all agree it's this part? Describe that interval. 2 to infinity. Where's it decreasing? Where's it constant? Negative 2 to 2. Anybody struggling with this? Is which one supposed to be negative? Yes, I'm sorry. Yes. Somebody said they're confused about what? Okay.